this is my second report on defining what is limits. So let's move forward to the properties of limits, calculus 2. So we have 7 properties that can be defined the limits. We'll solve to define the limits. So the first one is the limits of C approaches to as x approaches to A. So if we evaluate the limit of a constant, as x approaches to a, that is only equal to the limit of or to the constant itself. So the limits of the constant value is the constant itself. So let's have an example. Let's evaluate the limits of 8 as x approaches to 1. Notice that there are not any x term here, so it says by property number 1, this one, whenever we evaluate the limit of a constant, that is considered equal to the constant itself. So our constant value is 8. So the answer of limits of 8 as x approaches to 1 is equals to 8. That is our property number 1. The next property we have is the limit of x as x approaches to a is equals to a. This one, if we evaluate the limit of x as x approaches to a, that is not only equal to the value of a. For example, we need to evaluate the limit of x as x approaches to 4. So we need to find the value of our x, or our a rather. So in our given, the value of our x here is 4. For information, our a is any real number or any real value. So if we evaluate our limits of x as x approaches to 4, our answer is 4, because the value of our a, our real number or real value, is 4. So the limits of x as x approaches to 4 is equal to 4. That is our second property. If we say limit of x approaches to a. The third property is the limits of c, which is our constant, x as x approaches to a. This always we can factor out the constant outside of the limit and multiply it by the remaining f of x inside. We have the symbol determined by the limit of x. So limit cx as x approaches to a is equals to c times for our limits of x as x approaches to a is equals to c and a. So this can be only equal to the constant multiplied by a. For example, evaluate limits 2x as x approaches to 2. So all we need to do is to, this one. Limits 2x as x approaches to 2 is equals to our c as a constant times to our limits x approaches to is equal to 2. Our value of our constant here is 2. So we need to put here the 2. And then the value of our a, which is 2 ulit. So we need to put the 2 here. This is our constant and this is our real number. So if we times that, multiplied by 2 times 2, we can come up to the answer of 4. So that is our limits value. So we can cap off to the answer of 4. That is our property number 3 on how to solve it. Only equal to the constant multiplied by a. The next property is we have the limits of f of x plus minus of g of x as x approaches to a equals to our limits f of x plus positive and negative g of x as x approaches to a. So, limits of two functions, f of x, g of x, in addition and subtraction as x approaches to a. Notice that we can distribute the limits. We can evaluate first the limit of f of x as x approaches to 2i plus minus the limit of g of x as x approaches to a. So, we can distribute the limits if we had a product or if we have some indifference of f of x. So, let's have an example. Evaluate the limits of 3 plus x as x approaches to negative 1. So let's distribute first the property. So we have limits of 3 of x plus x, limits of 3 plus x as x approaches to negative 1 is equals to, first let's distribute the distribute the f of x. So we have the limits of 3 and as x approaches to negative 1 plus limits of x as x approaches to negative 1. So our limits of here can come up with the limits of the value of our x here, or our a, which is the 3, and our a here, which is the -1, the 1, 1. Then 1 plus quantity of -1, so we can come up with 3 minus 1. So 3 minus 1 is, we have the answer of 2. So that is our answer. That is the property number 4. Next, the property number 5, we have the limits of f of x over the g of x as x approaches to a is equal to limits of f of x as a approaches to a over the limits of f of x as x approaches to a as x approaches to a, and g of x is not equal to 0. So in this property, all we need to do is the denominator should not equal to 0. So limits of f of x over s of x is x approaches to a. We can distribute the limits sign on the numerator such that the limits of f of x as x approaches to a. Given this denominator should not equal to 0. If the denominator becomes 0, we have the undefined function. So let's distribute the limits as the constant limits of 2 is equal to x. So we have the example. Evaluate the limits 2 over x as x approaches to 4. So we can come up in this answer. Limits of 2 over x is x approaches to 4 is equal to limits of 2, which is our numerator, as x approaches to 4 over the limits of x, which is our denominator, as x approaches to 4. So equals to 2 and over 4. So we can come up to the answer of 1/2. That is our property number 5. Next, the property number 6. Limits of f of x raised on of n as x approaches to a is simply equal to the lead quantity limit of f of x raised of n. If we had this type of limits, we can evaluate the limits of the x approaches to a limits L, and we raise to n, which is our certain number that is exponent. So let's have an example. So evaluate limits of x raised to 2 as x approaches to 2. So limits of x raised to as x approaches to 2 is equals to quantity of limits of x as x approaches to 2 raised to 2. So our x, the value of our x here is 2. So we can come up in the answer that quantity of 2 raised to 2. So 2 times 2, or 2 times 2 is equals to 4. That is the answer of our property number 6. That is how we go on the property number 6. And the last property we have is the limits of square root of f of x as x approaches to a simply equals to square root of limits of f of x as x approaches to a is equals to square root of L. So let's have the example. Example E, evaluate the limits of square root of 2x as x approaches to 2. So limits of 2x as x approaches to 2 is equals to square root of quantity of limits 2x as x approaches to 2. So let's simply distribute the right at the inside, which is the 2 here. So this one, we can come up in this one. So square root of 2 limits of x as x approaches to 2. So our x, value of our x is 2. So 2 times 2 is the square root of 2 times 2 is equals to 2. So that is the last limits of our property, or the property of limits. I hope you have enjoyed and you have learned a little. So let's keep watching on my next video. Thank you.